Up next, Concept is King.
You're listening to Off to Market with Scott Farley and Hamish Chadwick.
Thanks, Hamish, and hello, everyone. Okay, so here at F3, we sort of feel like the sort of underlying motto we have is the concept is the king. If you don't get the concept right, then whatever you do beyond that point is sort of building on sand. Very important to, with everything you do in these projects, build it on rock. So whether it's IP strategies, pipeline, sales pipelines, whatever you do, it has to be built robustly so that it can't just be knocked out through a single fault. So I guess there's a trend in our industry that to go straight to CAD with concepts, and I'm dead against it. I still use hand sketches, but generally a lot of my concept generation is in my brain. So however you can fail quickly and cheaply, you should fail that way. Explore, experiment mentally with hand sketches, taking apart, chopping it up. I mean, some of my prototypes are just a bit of C-section, the twin cam, the Core Loops twin cam dog collar. To prove that point, that was invented by me, the solution for the two quick cams, and I actually just took a profile. I'm talking about a file and a hacksaw with a C-section, a drill, a pin.
Just for listener benefit, what is a C-section, Scott?
Oh, it's just a section of aluminium which is shaped like a C. And there's not a way of making children. there's another C-section. It's not that one. But it's just a section of aluminium in a C shape, and I just chopped it up, put a pin through it, and put a bit of webbing in it, and it locked and it worked. So they're called little proof of principle jigs, but it allows me to sort of take a concept beyond just a thought and prove it a little bit before I take it higher. But the whole idea is to and as we talked about before, fail early. You want to fail a lot early until you've evolved all the bugs out of it, and then don't fail at all late, because that's when it becomes expensive. And the benefit, I guess, of having a very good concept, and I use there's a few evolutionary stages. First of all, we sit and we talk a bit. We really find out what the resources are, what the client wants out of a result, what the market needs. I go and do market research, find out who I'm designing for, try and become that person, morph into that person so that I'm designing for the right person. And then you're basically going along and you're experimenting, you're seeing things, you're looking at things, you've got a set of criteria in your mind you want to meet, and you're just mulling things over in your brain. I'm very lucky to have a very visual imagination, and I got in trouble a lot at university because the lecturers wanted to see hand sketches progressing things through, but even hand sketches are too slow. You can't just sketch and evolve something. You really got to think of 1,000 different ideas in a morning and test them against the ergonomics of shipping, the manufacturability, how they're going to mate together, what materials you can use, is the market going to want it, your user function. There's 1,000 different things you have to be thinking about, and the easiest and most efficient way of doing that is in your mind. So at a quiet time, it might be at 2 a.m. or whatever, when you're not thinking of anything else, you can chew through these ideas, and you can chew through hundreds of ideas in the morning, and you're just basically analysing them, proposing them, analysing them, critiquing them, and you might come to work and you might sketch a few things up and try and take the next level of development. And you use a different part of your mind, actually, when you're thinking about something, and when you're drawing something, you're using another part of your mind. So it allows you to critique it in a different way. And so you might draw it up and go, well, that doesn't work. In my mind it seemed to work, but now it's going to interfere in this way, it won't work. And then again, when you start making something with your hands, you use a different part of your brain, and you'll uncover other issues. And then when you're doing CAD, the same thing happens. You're uncovering other issues using other parts of your brain. But as you go along the process, from thinking, which you can chew over hundreds of ideas in a morning, to drawing, you're really restricting yourself a bit there. You might use it. My folder is generally full of a lot of notes, and then a lot of chicken scratches, exploration scratches, and they start evolving into a drawing. And then I have a stage process where I put a brief together, so we find out we're on the right track, and list some criteria, and then we go for initial concepts, where you start taking all those chicken scratchings and thoughts and start evolving them into, say, three or four options that solve the same problem in a different way. So you solve it one way, then you just throw that in the bin. you go back to the idea again, start again, and you solve it another way. In one way, you might be looking at some existing product that already exists that you already have in your product line, adapting that. The next way is starting from scratch. Another way might be using a different manufacturing material. One may be a top-end version and a low-end version, and then you put them in front of the client, and you can look at them and critique them, and you might take aspects of one design and put it into another, and you get this evolution. And then from that, you do a final concept, which is hand sketches of all that in a far more detailed manner. And my final concepts are very detailed, and they take into consideration manufacturing process and all the rest of it. And the reason for that is because when you get to CAD's a fantastic tool, and it's just made our job so much easier. It allows you to prototype, go straight to tooling. It is really, really handy and a massively valuable tool, but it's very time consuming. And you can't change CAD easily. So if you notice, if I was to show you all my final concepts, they're very, very, very similar to the product that goes to market, because I do all my thinking early. And then what it allows you to do is draw a line in the sand between design and engineering. So after the thinking and the final concept's done, the drawings and all the rest, and the drawings are simply a communication tool. They don't really help my process as much as they help communicate with the client and learn and critique, so the client can get a really good idea of where we're going, and we can use it. I've used it for to get feedback from industry leaders, people who really know the industry, so you can go along and get a lot of information off them because they know the market very well. If you put a concept in front of somebody who's very knowledgeable about a market and they pull it apart, you've got some work to do. You've got to refine that. So it gives you an opportunity to go back and fix that first before you go to manufacturing. So when you get to the end of the design, the final concept, which is a really detailed drawing of exactly what you want, you can sort of stop the design process, and it does save a lot of time down the line, because then when you're doing a CAD, which is the most time-consuming part of it, the engineering part of it starts, and you're no longer experimenting at that point. You're really just capturing what you've thought about and detailed it in the concept. And so you get the right concept, all the rest of it flows much easier, and you end up, even though you might spend money doing the concept stage, you've fully evaluated that product, and you know that everything down the line, you'll probably end up saving twice the money you spent on the concept phase by saving yourself money in the engineering phase. It makes it far more fluent. So that's what we do here at F3. And obviously everyone's got their own ways of doing things, but just realise that CAD, when they do demonstrations, they've done it 1,000 times. They don't have any engineering detailing it. I run Creo, which is a really high-end engineering package for CAD. But CAD is computer-aided design, so that's the things you see with the pretty pictures. And you can develop things up there beautifully, but when you see demonstrations, they whip through an idea. It's very base level. It's usually done on the surface, so there's no engineering behind it. The engineering part of it, all the detailing, the drafting, the rounds and everything to get it out of a tool and make it work, takes days and days and days for every little feature. So you don't want to be making change at that point. In fact, sometimes when you have to make changes, they're called parametric programs. So if I have 3 parts in an assembly, which is, if you had a product that was all joined together, that's an assembled product. The same thing with CAD. When you have all your models, all your parts, you put them together in the CAD so you can see how they all fit together and move together. Sometimes you'll have to build a part off another, and if you make a modification to a dimension on one part, a parametric program will change the other part, which is really handy because you can, sometimes you have to change dimensions, and all of a sudden you only have to change one part, the other one updates. But when you get right down to the full detailed part, which means it can be manufactured, a lot of those changes are too much for the computer. So a small change in a very final CAD program can take days, if not weeks, to rectify. So client comes in and goes, let's just change this dimension here. And my heart just, all my energy drains out of me, and oh my God, this is going to take weeks to solve. So you really got to try and make sure as much as possible to solve all of your changeable aspects at the drawing phase, the thinking phase, and not take it into the engineering phase. Handy hints from Scott.
Yeah, that was incredible. So I think, like you said, concept is king.
Keep thinking.
I think you should get a T-shirt.
Done.
Thanks, Scott.
You've been listening to Off to Market with Scott Farley and Hamish Chadwick.